Hi, my name is Ziya. I come from Innsbruck. I know many people know Innsbruck not too much, so I have a quick introduction again. Innsbruck is a China-based leading total solutions provider for data center, cloud computing, and big data. Innsbruck provides hardware products, including servers, HPC servers, supercomputers, AI platforms, switches, and storage servers. In server market share, Innsbruck is top 1 in China and top 3 in the world. In supercomputers market share, Innsbruck is top 3 in the world. Innsbruck also provides software, including enterprise resource planning, human capital management, and big data softwares. Innsbruck also provides solutions for enterprise cloud, public cloud, HPC, and AI. In China, Innsbruck is a top 1 provider in government cloud. Actually, Alibaba Cloud and Huawei Cloud are our competitors. Innsbruck Cloud is a subsidiary of Innsbruck Group. This is my talk today. I will compare OVS and Tungsten Fabric vRouter. Tungsten Fabric is an open source version from Juniper Contrail. Contrail is a Juniper Commercial product, Contrail. Tungsten Fabric includes SDN controller, orchestration layer, and vRouter. vRouter is similar to OVS. Tungsten Fabric can support containers, virtual machines, and bare metals. Tungsten Fabric vRouter has 2 implementations, kernel module and DBDK. It's very similar to OVS. Here are OS architecture and Tungsten Fabric vRouter architecture. Here in control plane, OS uses OpenFlow and OSDB, but Tungsten Fabric vRouter uses XMPP. It's extensible messaging and presence protocol. Actually, many applications use this general protocol. In data path, OVS vSwitch daemon uses netlink to communicate with data path. Tungsten Fabric vRouter also uses netlink to communicate with vRouter DBDK. For flow table, OVS has hierarchical tables, including mega flow table and EMC. But in Tungsten Fabric, just 1 level table. Actually, every tenant has its own next hop table and flow table. Here is a thread model. In OS, PMD thread will receive packets from the first execute, then does match and executes actions, then flushes the TXQ, then do the same things on the other executes. But in Tungsten Fabric forwarding thread, Ix function will receive all the packages just from all the packets from all the Ix queues, and distribute packets to Ix ring buffers of other forwarding threads. Then the forwarding thread will get packets from its all Ix ring buffer, then route them. Routing includes decap, lookup flow table, lookup next hop table, maybe incap, and output the packets. For flow table, OS has hierarchical tables. In slow path, it has open flow table. In dead path, it has a mega flow table, EMC table. Actually, Megaflow uses a tuple-based search and includes many subtables. Subtable is a hash table. EMC has one hash table per PMD thread. For hash collision, it uses a linked list. For OS DBTK, actually, it has some optimization. It has dead play classifier tables per ingress port, and subtables are sorted in descending order by hit rate. But in Tungsten Fabric, it has only one huge hash table. For hash collision, it also uses a linked list. Actually, all the forwarding threads use the one common flow table. For Ix and TXQ assignment, OS is configurable. You can use OS-based control to assign different Ix queues to different forwarding threads, PMD threads. For TX queues, they are configured automatically. In Tungsten Fabric, it's fixed. Actually, a queue will be assigned to a recently least used forwarding thread. For physical NIC, number of Ix queues and TX queues are equal to number of forwarding threads. So it depends on how many forwarding threads you start. For virtual NIC, by default, only one Ix queue. Every forwarding thread has a TX queue for every VNIC. For Ix packet distributing, actually OS does nothing. But in Tungsten Fabric, it will distribute Ix packets to other forwarding calls. Actually, for MPS over GRE packets, it's very necessary to distribute these packets because actually NIC will calculate ISS hash and use ISS hash to distribute packets to queues, Ix queues. But for MPS over GRE, for all the flows, it's ISS hash is the same. So just the first queue can receive these packets. So it's necessary to distribute packets. For tunnel types, OS can support many tunnel types, but it cannot support MPS over UDP. For Tungsten Fabric, it just supports 3 VX tunnels. VXLAN, MPS over GRE, MPS over UDP. But in reality, actually, core network is an MPS network. So OS should support MPS over GRE and MPS over UDP. But currently, it only can support MPS over GRE. I know an OH guy mentioned OS should support MPS over UDP because routers cannot distribute MPS over GRE by ECMP. For SRIV, actually, OS does nothing. I know OpenStack can support this by SRIV plugin, but if OpenStack uses SRIV plugin, actually, it doesn't involve OS. But in Tungsten Fabric, you can use SRIVF or SRLVF bound and its physical interface. You also can attach SRIV interface to VM by Tungsten Fabric control plane. So Tungsten Fabric can support SRIV well. For SRIV, actually, it has some issues. For example, VM live migration. You cannot communicate between regular VM and SRIV VM. vRouter cannot control the traffic from and to SRIV VM. Actually, some smart NICs can handle them because its VF can support VTL protocol, like Intel Matkisk smart NIC. For LP processing, OS just broadcasts LP request. But in Tungsten Fabric, it doesn't broadcast. It will use VIP MAC or host MAC to reply LP request. Actually, vRouter not only handles L3 routing, it also can handle L2 switching. vRouter is a default gateway for local VMs. vRouter will not forward LP packets from physical fabric to local VMs. For hardware VTAP support, OS uses OSDB, but in new Tungsten Fabric version, it uses UVPN VXLAN because this control plane protocol is more scalable. Actually, UVPN can fix many challenges in data center interconnect. It can bring many benefits. UVPN is a new protocol suite to fix DCI challenges. In control plane, it uses MPBGP to handle MAC learning. For data plane, it can use VXLAN, MPS over GRE, etc. Actually, in Tungsten Fabric, it has integrated VXLAN and UVPN, so it can handle UVPN very good. Here is the figure from Juniper. You can see here in VXLAN domain, you can use IGP for control plane. You can use VXLAN for data plane. For core network, you can use BGP for control plane. You can use UVPN tunnel protocol for data plane. It depends on what type your core network is. If core network is MPS, you can use MPS over GRE. Here is EVPN do decamp, encamp. You can read details offline. Here, let's summarize our comparison results. For control plane, OS uses OpenFlow, but you know OpenFlow will not have next version anymore. Maybe P4 is next, but you know OS is not ready for P4. But for XMPP, it will not be obsolete recently. For flow table, OS is better, but Tungsten Fabric vRouter is bad. For IX and TX queues assignment, OS is flexible, but Tungsten Fabric vRouter is fixed. For IX packet distributing, OS does nothing, but Tungsten Fabric vRouter can do well. For tunnel types, OS can support many tunnels, but it cannot support MPS or UDP. Tungsten Fabric vRouter can handle MPS bankable very well. For SIAV, OS does nothing, but Tungsten Fabric vRouter can do well. For IRP processing, OS just broadcast, but Tungsten Fabric vRouter can handle it very well. For hardware VTAP, OS just use OSDB, but Tungsten Fabric use VPN VXLAN. For total UVPN support, OS does nothing, but Tungsten Fabric vRouter can support totally. So I'm done. Thank you.
Let's thank our speaker. All right, and we have plenty of time for questions, so step up to a mic.
Hi, thanks for the presentation. I just wanted to mention that it seemed like you're kind of comparing the OVS data plane with a particular application, which Tungsten seems to be providing, things like routing. OVS doesn't actually provide that, but there are applications like, NSX that VMware provides, or OVN, and other projects that actually provide that functionality. So things like the ARP suppression are handled through that. So it's certainly possible to do that with OVS, but it's going to depend on the application that's used, not on OVS itself.
Yeah, actually, Tungsten Fabric is a total solution. OS just for L2 data plane. So, yeah.
Right. Yeah. So it's not. I think it's not inherent in OVS that things like ARP can't be handled. It's going to be dependent on how the application handles it. And so there are, like OVN handles that. It wouldn't just broadcast all the ARP packets, for example.
Okay.
And then you had mentioned that about OpenFlow being used for the control plane and that it's not being updated. That is true. However, there are a number of extensions to OpenFlow that we've been adding from the beginning. So we continue to add new features to the control plane, even beyond OpenFlow, because OpenFlow is designed in such a way that new features could be added. So it does continue to evolve for us. I could see eventually using something like P4, but we're not tied just to the features that OpenFlow provides.
Okay, but for OpenFlow, I know ONF will not do anything more, right?
Correct.
If we support a new protocol, how does OpenFlow handle?
But OpenFlow has the ability to be extended, and so we have Open vSwitch extensions to OpenFlow. We've had that from the beginning, and so we continue to add features that OpenFlow doesn't have by using those extension mechanisms.
We routinely add support for new protocols, for example.
And then I had a couple questions about things like, you had mentioned that OVS doesn't do any sort of receive packet distribution, but we do based on RSS. I understand that if OVS were to support MPLS over GRE, that would be difficult because the RSS hash wouldn't work. But you had it listed as no for receive side distribution, but I think OVS does have that capability. I was confused by that comment.
Actually, if for example, if you have 3 flows for inner packet, for MPS level, maybe it's the same. So even you have 3 flows, but for MPS over GRE, just 1 hash value for this. Right? So only one IXQ can receive it. In OVS PMD thread, only one thread can handle 1 queue, right? So it cannot distribute packets.
Right. If there's not something to hash over the packet, but as you mentioned, OVS doesn't support MPLS over GRE.
Yeah, I know.
So, but most protocols, or for example, like VXLAN or Genève, a lot of them would be distributed because of the layer 4 port that is part of the hash.
But for VXLAN and Genève, because it will calculate outer headers for source port, right?
Right.
Source port will be calculated from inner packets.
Correct.
So it can be distributed.
Yeah, exactly. So OVS does support some distribution, but it wouldn't support it, like just bare MPLS, for example, it probably would not support it because there isn't that entropy to distribute it. But then how would it work how does Tungsten work anyway if otherwise don't you end up with packets that are received out of order if you are just hashing it randomly?
For Tungsten Fabric router, every forwarding thread will receive packets, then calculate ISS hash from inner packet.
Okay, so
then
it
depends on hash value to distribute packets to different other forwarding threads.
Okay, so it decaps the packet and then it distributes it afterwards.
Yeah.
Okay, great. Thank you.
Hi. I have just a small question for you. I really enjoyed your comparison. Do you have a sense of scalability of the two solutions? For example, does one lend itself better to tens of thousands of flows and the other to tens of millions of flows? Did you do any comparison to that effect?
Sorry, your voice is very, very low. Can you speak high?
Okay. So I was wondering if you did any comparison with regards to scalability. So the flow table of OVS versus the distributed flow tables of vRouter. Did you notice that one was easier to scale than the other?
Okay, you mean for scalable for flow table?
Yes, scalability of the flow table in terms of number of entries.
Okay. Actually, in Tungsten Fabric vRouter, we have a very, very big flow table. It's a big hash table. So I remember Juniper guys said it can handle about 100 million flows. So I think flow number of flow is not an issue. So what's your question?
And is that the same capability that you noticed with OVS?
Yeah. Always uses a hierarchy flow table to handle performance issue. Tungsten Fabric vRouter doesn't do well. But actually, in last year, I optimized it by use flow cache. It can boost performance very highly. In my work, I can improve performance by 50%. So yeah, Tungsten Fabric vRouter does worse than OS.
Thank you.
All right, let's thank our speaker one more time.